Hello everyone, myself Vanita MH. I am working as a lecturer in Government Polytechnic Carpet. I heartily welcome you all for this session. In this session, I am going to present you an ARM controller Unit 2, that is ARM instruction set. In this session, I am going to speak about the fundamentals of ARM instructions, data types and ARM data types and conditional execution. Learning outcomes. Learning outcome means after seeing this session, what you will be able to understand. It means after seeing this video or PPT, what you learnt from this. I 100% assure you, my dear students, after seeing this session, you will be able to understand the fundamentals of ARM instruction set and its data types, and also you can easily illustrate the conditional execution with an example. Okay, before moving on to the fundamentals of ARM instructions, I want to recall some points about the ARM. In Unit 1, I think, my dear students, you all learnt about the ARM. What do you mean by ARM? ARM is a advanced RISC machine. As the name itself is telling, it is a RISC machine. RISC means reduced instruction set computer. It is based upon the RISC architecture. ARM is a 32-bit processor. You know that one. It's a 32-bit processor, and compared to other microcontrollers or processors, our ARM is having a special characters. What is that special character our ARM is containing? Firstly, our ARM is highly pipelined. You know what do you mean by pipelining, my dear students? Pipelining means executing the instructions parallelly. Parallelly means while executing the one instruction, our ARM processor will be doing some task with the other instruction. So parallel you are executing so that the performance of the processor will be very faster compared to other processors. Then our ARM is having a hardware debug technology. It is incorporated with hardware debug technology. Then our ARM processor is having a structure called von Neumann architecture. You know what do you mean by von Neumann architecture? In Unit 1, you learned about two architectures, that is hardware architecture and von Neumann architecture. Our ARM is incorporated with this von Neumann architecture. It means it is containing a 32-bit bus, which is the single 32-bit bus, which will carry both address and data simultaneously. That is a von Neumann architecture. Then at present we are using a version of ARM 7, that is ARM 7 TDMI processor we are using at present. What do you mean by this ARM 7 TDMI? ARM 7 means it's a version. The 7 will indicate the version. TDMI means T stands for thumb, D stands for JTAG debug, M stands for multiplier, and I stand for IC. IC means in circuit emulator. I told you the special characters of ARM, that only indicated by this TDMI. TDMI means it is containing a thumb instruction. D means it is, I told you, it is containing a hardware debug technology, that is debug. Then it is also containing an in-circuit emulator. This is, you all learnt this in Unit 1. I just recall that one because to continue with the ARM instruction set, you should know properly about the ARM first, right? So now we will start our session, that is Unit 2, that is ARM instructions. Before going on to the ARM instructions, first we will see what are the fundamentals of ARM instructions. So the ARM is a 32-bit processor, you know that one. Our ARM mainly defines two instruction sets. The one will be the ARM state, that is it supports 32-bit instructions, and second will be the thumb state, that it supports 16-bit instructions. Then ARM is a 32-bit processor. Then When it is 32-bit processor, what are all registers, what are all instructions it is performing, that should be a 32-bit, right? In microcontroller it's a 8-bit. You know that one, the microcontroller is a 8-bit. So what are all registers, what are all instructions you are using in microcontroller, it is 8-bit only. Likewise, in ARM, it's a 32-bit. Instructions are all 32-bit long. So there are 2 to the power of 32 possible machine instructions are there in our ARM. Then our ARM mainly supports load and store architecture. What do you mean by this load and store architecture? In ARM, we don't have data processing instructions to manipulate data within memory. It means you don't have any instructions to change the data within a memory. So, before doing any operations, you have to fetch the data from the memory into the register. Then you have to manipulate that one. For doing all these operations, you need this load and store architecture. Load and store architecture means loading and storing. You are performing the two operations, that is loading and storing. Before using data, any data, we have to store the data somewhere. It means permanently you have to store the data. If you store the data in a register means you can't use that register for further functions. If you use that register for further function means the data will be erased. So, to save the data permanently, we have to store the data in a memory. In a memory, we don't change the change of data is not possible. So, if you store the data in a memory means you can fetch the data whenever you would. Multiple times you can fetch the data. So, our ARM is supporting only register to register movement, register to memory movement and memory to register movement. But our ARM won't support memory to memory movement. Means memory to memory movement is not possible in our ARM. You keep in mind, memory to memory movement in ARM is impossible. So, before doing any data manipulation, you have to store the data or fetch the data from the memory. Then you have to do the manipulation in register only, right? Okay. Now we will see what do you mean by this load and store architecture. Loading. What do you mean by loading? You already saved some data in a memory. Now you want to take the data into the register, right? For doing or fetching the data from the memory, it means getting the data from the memory is called loading operation. Then what do you mean by storing? Before fetching, we have to store some data in memory, right? So, for storing, for putting the data into the memory is called storing operation. So, we can, in ARM, we can read or write the data from the memory only by using this load and store architecture. Next, in ARM, we have to move data values into the register before using them. I told you already. Before using the data, you have to move the data from the memory into the register so that you can manipulate the data in a register, not in a memory. Next, our ARM will support 3 address data processing instruction. What do you mean by this 3 address data processing instruction? You see here, there is an instruction syntax here. First, there will be an instruction. Next, there will be a destination register RD. Then source register 1 RN and source register 2 RM. This is 3 address. See, destination register is having one address, source register 1 is having another address and source register 2 is having another address. It means it is 3 address data processing instruction. This instruction will indicate what operations you are going to give to an ARM to perform. Here I took an example like add R3, R1, R2. So add will perform an addition operation of 2 operands. You know that one. So this instruction will do an addition of register R1 and register R2. The contents of register R1 and R2 will be added and the what result you will get, that will be saved in a destination register RD, that is R3. This is the addressing the data processing instruction that our ARM will supporting, that is 3 address data processing instruction our ARM supporting. Okay. Next we will see The ARM supports only the conditional execution of every instruction. What do you mean by conditional execution? Conditional execution means you are telling an ARM to do some operation by seeing the condition what you are giving. It means you are telling an ARM or commanding an ARM or giving a command to an ARM to do some instruction manipulation only when that condition is satisfied. That is called conditional execution. That we will see in detail in the next sessions. Next, our ARM has three sets of instructions which interact with main memory. I told you to interact with the main memory, we have to go for this load and store architecture only. What are the three sets of instructions which interact with main memory means? The first one will be the single register data transfer, that is LDR and STR. LDR and STR means load register and store register. In single register data transmission, you are using a single register data. Only the single register data you are moving into the memory or fetching from the memory. That is LDR and STR. The second one will be the block data transfer, that is LDM and STM. LDM means load multiple, STM is store multiple. Multiple means more than one register data, that is multiple data registers. Multiple register data will be transmitted into the memory or fetched from the memory, that is called block data transfer. Then lastly, the single data swap, that is SWP. The swap means the contents of one register will be swapped with the another one, that is single data swap, that is SWP instructions. The next we will see the data types. What do you mean by data type? This will indicate which type of data you are using to store the data. I told you we have to store the data in a register. Before storing the data into the register, you have to select what type of data you are choosing. That will indicate the data type. Our ARM processor will support the following data types. What are they? The first one will be the byte. You know what do you mean by byte? The 8 bits are called byte and the 4 bits are called nibble. You know that one. The grouping of 4 bits is called nibble and group of 8 bits is called a byte. That is the first data type, that is a byte. The second will be the half word. Half word means it is a 16 bits. 16 bits means it is aligned to 2 byte boundaries. Then third one will be the word, that is 32 bits. It means it is aligned to 4 byte boundaries. And lastly, the double word, it is 64 bits. So, there are 4 possible data types. Tell me, first one will be the byte, 8 bits. Second will be the half word, 16 bits. Third will be the word, 32 bits. And fourth will be the double word, 64 bits. Okay, now we will see which type of data is selected for ARM. Which type of data ARM is selected? I told you ARM is a 32-bit processor. What are all instructions, what are all registers we are going to use in our ARM is 32-bit long only. To save 32-bit long register or an instruction, we have to go for 32-bit word only. So, what is the data type in our ARM? It's nothing but a word. Word means it's a 32-bit. So, the ARM data type is nothing but a word. That is 32-bit. That word can be divided into 4 8-bits. Next, our ARM address can be a 32-bit long and it can be configured at power up as either big endian and little endian mode. While storing the 32-bit data into a memory, we can go for 2 possible modes, that is big endian and little endian. Now we will see what do you mean by this big endian mode. This big endian mode means the most significant byte of the word means it's a 32-bit, okay, that in that 32-bit word, the most significant byte is stored in the lowest address, that is big endian mode. Here consider this example. I took an X number 34569312. Okay. Now you have to store this X number into the memory by using a style called big endian mode. In big endian mode, keep in mind the most significant byte. In this example, the most significant byte is nothing but 34. That should be loaded into lowest address. In this memory, which will be the lowest address, dear students? The 0 is the lowest address. So, in this 0, you have to store the most significant byte, that is 34. It is stored. See here, in address 0, 34 is stored. In the next address 1, the next number byte 56 is stored. In address 2, 93 is stored, and in address 3, 12 is stored. This is the big endian style. Now we will see the little endian style. What do you mean by little endian style? In little endian style, the least significant byte of the word is stored at the lowest address. In this, consider the same example. In this, the least significant byte is 12. This is the least significant byte. This least significant byte is stored in the lowest address. Which will be the lowest address? 0 is the lowest address. In 0th lowest address, the least significant byte, that is 12, is stored. In the next address 1, 93 is stored. In next address 2, 56 is stored. And in next address 3, 34 is stored. Likewise, you can arrange the data types, or you can arrange the datas in two address modes like big endian style or little endian style. Next, we will see what do you mean by conditional execution. Our ARM instructions are all conditionally executed. Condition executed means you will specify some condition with an instruction to an ARM. You are telling an ARM processor to do or perform the instruction or do the task only when the specified condition is true. If that specified condition is true, then only it will perform the given task. If that is false, it won't execute that instruction. Why we need this condition execution? This condition execution will increase the performance and code density. Starting only it will check whether the condition is true or false. If it is true, then only it is performing. If the condition is false, then also it is performing, means the performance of the device will be slower, right? So first we will check the condition. If that condition is true, then you do for the next one. While doing this one, you can increase the performance of a processor and also the code density. Then the next one is this conditional execution reduces the number of branches, which also reduces the number of pipeline flushes, and also this improves the performance of the executed code. That's why we have to go for this conditional execution. Then this condition execution depends upon two components. Which are they? One will be the condition field, another will be the condition flags. What do you mean by condition field? This condition field is located in the instruction itself. You are giving some instruction to the ARM processor, right? In that instruction only you are appending that condition field. Then where is the condition flag? The condition flags are all located in the CPSR. CPSR, you know, it's a current program status register that is containing the flags, different flags. That is located. So the condition flags are all located in the CPSR. Next, we will see one simple example. Consider here. Dear students, I tell you one instruction. You please tell me what ARM will perform. Okay. Write down the add R0, R1, R2. What it will do? Add means it's addition operation. You are giving R0, R1, R2 means the contents of the register R1 and the contents of the register R2 will be added, and the result will be stored in a destination register R0. It's a simple process. You are not giving any condition, nothing. You are just simply telling the ARM processor to perform the given task. But now consider this example. Add EQ R0, R1, R2. Here I am appended one condition, that is EQ condition. EQ means it's equal. EQ condition with the instruction. So add EQ R0, R1, R2. Now our R won't execute the instruction simply. It will see, oh, they given some condition here. I have to check whether the contents of register R1 or R2 are equal or not, I have to see that one. If that condition is true, then only I have to go for the next instruction. Otherwise, I have to leave this instruction. It will think like this, and it will see the condition, what condition you are given. Here, the contents of register R1 and R2 will be checked. If the zero flag, if they are equal, means the zero flag will be set. It means Z flag will be equal to 1. If the Z flag is equal to 1 in a CPSR, then it will start to perform the addition operation of R0, R1 plus R2, and the result will be stored in a R0. See here, add EQ R0, R1, R2 means R0 will be equal to R1 plus R2 only if zero flag is set. It means EQ condition is checked only. It will execute this instruction if Z is equal to 1. Right? This is the table of mnemonics which is mainly used to do the conditional execution. It is containing some mnemonics here. EQ means it's equal. I told you EQ means it will check for an equality. That is, it will check whether the zero flag is set or not. If zero flag is set, then only it will execute the instruction. Otherwise, it won't execute the instruction. Now, I will consider one more example, that is NE. NE means not equal. Not equal means zero flag will be clear. You know that one. So, I will go for the last slide. See here. Just use change here. Take down my dear students. You do this one. Add EQ is there, no? You take down now. ADD NE R0 comma R1 comma R2. What it will do? What it will do? NE means it is not equal. See here, it's not equal. Not equal means zero flag should be 0. Right? Zero flag should be clear. Now, that will check whether the contents are 0 or not. It will see. If the zero flag is clear means, then only it will perform the operation in this condition. Add NE means it will check whether it is equal or not. It means the zero flag should be cleared. If the zero flag is cleared in CPSR, then only it will perform the addition of R1 plus R2, and the result will be stored in a destination register R0. You understood now? Next we will be having carry clear, carry set or HS. HS means unsigned higher or same. If it is CS means you have to set the carry. Carry means C is equal to 1. In an instruction, if there is CS means it will check for a carry. If that carry is 1, then only it will perform the next instruction. Otherwise, it won't. It leave the instruction. Likewise, next will be the CC slash CO. LO, the carry clear or unsigned lower. Here the carry will be cleared. If the carry is 0, then only it will execute the instruction. Then MI stands for minus. It will check whether the given numbers are negative. If the negative means the N flag will be set. If that N flag is set, then only it will execute the next instruction. Then PL means plus or a positive. It will check whether the number is positive or not. It means N flag will be equal to clear. Then VS overflow. If the overflow flag V is set, then only it will execute the instruction. It will check for the condition. All these things will tell you, it will check for the condition. If that condition is true, then only it will execute the next instruction. Then VC means no overflow. It means overflow flag V will be clear. Then HI, unsigned higher. In unsigned higher, zero flag should be equal to 0 and carry flag should be set. It's 1. Then LS, unsigned lower or same. Zero flag is set or carry flag will be cleared. Then GE, signed greater than or equal. Here, N flag should be set and V flag should be set, or both should be cleared. Then LT, signed less than. N flag will be set, overflow flag will be cleared, or N flag will be cleared, overflow flag will be set. Then GT, signed greater than. Here N flag and overflow flag will be set and zero flag will be cleared. Then LE, signed less than or equal. Here the zero flag will be set, or N flag will be set, overflow flag will be cleared, or N flag will be cleared or overflow flag will be set. Then AL, this AL is nothing but always. It's unconditional. It can be ignored. There is no value for this. It is an unconditional. So, my dear students, you have to keep in mind that these are all the conditional mnemonics that we are going to use in our ARM. Our ARM processor will check if you are appending some mnemonic to the condition instruction means it will check whether the condition flags here. This condition, it will check the condition flags in CPSR. If it is true only, it will execute the instruction. Okay. Next session will be the question bank and assessments. Till now I covered fundamentals of ARM instructions and data types and condition execution. Based upon this, what are all questions they may ask in an exam, I will tell you now. So this is the questions what they can ask from this session. First one, explain condition execution with example. This question was asked in November 2019 for 5 marks. My dear students, before going to answer the questions, just first read the question carefully and see whether they ask for 5 marks or 10 marks. And write relevant to the marks. Okay, don't I know you know all the answers, but don't write unnecessarily. Just you see the marks, how many marks they given, and you write relevant to that marks. If they ask for 5 marks means you write what you mean by unconditional execution, and 2 points you write why you need this the condition execution. You write that one, and if with examples means you give one example. I gave one example, right? You give that one. That is enough for 5 marks. If they ask this question for 10 marks means please write the table. In the table you take some 5 mnemonics and write the table. That is required for 10 marks. Okay. Next question will be the explain ARM data types with example. First you write what you mean by data type and what type of data our ARM is supporting. You write that one and give some example. Then explain big endian and little endian modes with example. You write what you mean by big endian and little endian first and take one example, and you take one example and split and use big endian and little endian mode to save the that content in a memory, how you are using in a big endian and little endian mode with example. I told you that one. Then list the fundamental features of ARM instruction set. List you see the you see the marks for how many marks it is given. It is 5 marks means you just write 5 points, it is enough. If they are asked for 10 marks means you write the 10 points. Okay, that's why I'm telling before answering just go for the questions, read carefully 1 or 2 times. You read that question carefully, what they asked and what you have to write and how many marks they are asked for. If it is 5 marks means you write for that only. If it is 10 marks means you write elaborately, you write. Okay. Okay. Next, we will see some multiple choice questions, my dear students, so that I can check whether you understood what you understood from this session. This is just a 1 mark, one objective type questions. Please answer this one. First, we will see first question. ARM has dash instruction set. I told you ARM defines 2 instruction set. What are they? ARM state and thumb state, right? So the answer is 2. B. The answer B, 2. So ARM has 2 instruction sets. Second one, ARM supports dash address data processing instruction. Just recall that one, that instruction syntax I told you. No, in that instruction syntax you will be having 3 address data, that is RD, RN, RM, right? So it's a 3 address data processing instruction. So ARM supports 3 address data processing instructions. Then third one, ARM instructions are all dash bit long. So you tell me ARM is a 32-bit processor, right? I told you ARM is 32-bit processor means it should support the instructions, registers, everything should be 32-bit only. So the answer is 32. Next one, ARM processor has dash architecture. They given load, store, none. Load means you can fetch, that's all. Store means you can put the information to the memory, but R is mainly used to fetching or storing. Both operations you have to perform. It means load and store both you want. That's why ARM processor has both load and store architecture. The answer is C. That is load and store. Next one, ARM is dash bit processor. You know this one. It is 32-bit processor. Always you remember when you ask for ARM, the 32, the number 32 should come in your mind. It is a 32-bit processor. Don't forget this one. These are all basics. So ARM is dash bit processor. It's a 32-bit processor. Next one, in dash NTN form, the most significant byte of the word is stored at the lowest address. My dear students, don't confuse with this big and little endian mode. I tell you one point. Before answering big endian, little endian, you keep in mind you always taking the lowest address. Okay? Consider the lowest address. If you are taken a most significant byte means it is big endian. You are taking a least significant byte means it is a little endian. Okay, don't get confused with this. So in this question what they asked, in dash endian form the most significant byte of the word is stored at the lowest address. Which one? It's a big endian, right? The answer is big. The next one, in dash endian form, the least significant byte of the word is stored at the lowest address. It's nothing but a little. In little endian form, you are saving the least significant byte of the word at the lowest address. Right? No confusion, right? Next will be the address space in ARM is dash. So what will be the address space? The ARM is a 32-bit processor, you know that one. You should not forget until you complete this ARM controller subject. 32, the number 32 should be in your mind. It's a 32-bit processor. That's why the space supported, address space supported by this ARM is nothing but 2 to the power of 32. That is nothing but answer D. That is 2 to the power of 32. Next question. Address system supported by ARM systems are dash. I already told you the address system supported by ARM is both big endian, little endian. Not only it won't support only the big endian and little endian, it supports both. So the answer is both little and big endian. Then lastly, all instructions in ARM are conditionally executed. They are asking whether this statement is true or false. It is true. You studied in the last session, in the last classes you studied. Its ARM is always conditionally executed. You are giving a condition to check that one. If that condition is true, then only you have to perform the operations that you are telling to an ARM. So the ARMs are conditionally executed. So what the statement given is true. So the answer is first one, that is true. A, that is true. My dear students, to prepare this PPT or a session, I referred a prescribed textbook called ARM System Developer Guide by Andrew N. Sloss. And also I referred ARM Assembly Language, that is William Hall. These two textbooks are very good textbooks. My dear students, I will suggest you one thing. You don't depend upon the notes or PPT or materials that your lecturers will be giving. You consider that for a small amount, but when you get the time, no, you have to study these textbooks because it will enhance or it will increase your knowledge. Don't stick on to the notes itself. For higher studies and all, this ARM System Developer Guide Andrew and Sloss textbook is there. No, it is very useful. You read that one and increase your knowledge so that you can study better. And okay, go for these textbooks and read. Okay, now I will complete my session. Before telling thank for you, I would like to thank Shant Kumar sir and Rangashamaya sir for giving me an opportunity to prepare this session. And also I would like to thank DTE for selecting me as a content developer for ARM controller for LMS team. I thank all my dear staffs And my dear students, I thank you all. Please go for this session or PPT so that it will be somewhat helpful for you. Thank you. All the best, my dear students. Read well. Nowadays, the corona is everywhere. Take care. Don't go here and there. Be careful. Take care about your health also. Not the life is not only studying. Take care. Be healthy and study well. Okay. All the best. Thank you.